Hi. Thank you for the introduction. My name is Rahul Padole, and I am here on behalf of Affordable Robotics and Automation Limited. Just give me a second. Oh my God. I really did not expect so many people here. So many bulls makes me feel a bit bearish. So I would like to introduce myself. My name is Rahul Padole. I look after new product development in ARAPL and ARAPL LAS, which is an IIM Ahmedabad backed company. We are one of the leading companies in India regarding robotic application, and the first company in manufacturing of autonomous forklifts in Asian, Australasian, and Indian countries. So we are a company in Pune who started in 2005 with a workforce of currently 400 people, valued at around 100 million USD, who specialize in welding automation and multi-level car parking. For the last 2 years, we have recorded we've recorded a 30% year-on-year growth, and ARAPL RAS is a subsidiary of ARAPL who have presence in the US market currently. These are some of our marquee customers. As you can see, we work with Tata, Mahindra, Bajaj, Lodha definitely for parking, and 100% of Bajaj rickshaws are made by ARAPL. These are some of our product offerings: automated robotic welding, robotic multi-level car parking, and warehouse automation. So in automated robotic welding, what we do is we manufacture chassis of two-wheelers, three-wheelers, four-wheelers completely from start to end. And if you might have ever heard from an OEM like maybe Maruti or Tata or Mahindra that they produce a car every 2 minutes or every 3 minutes, how that becomes possible is because of vendors such as us. So we plan how they will manufacture a particular chassis or a car through various stages. We tell them how many robots they'll require. We design their entire plant, entire process. And we basically manufacture the entire chassis. And we also do material handling from them, which means that we particularly pick up a chassis from one station to another. So this all happens usually between 80 to 150 seconds per cycle. All of you are from Mumbai, so I'm pretty sure that you guys are aware of automated parking across Mumbai. So there are those basic structures, metallic, where the car goes to a certain level, maybe ground, +1, +2, +3. We've made one which is around 72 meters tall, which is as high as Mumbai authority actually allowed us to go. Actually, I wanted to show a video, but that would not be possible. Warehousing automation, we are currently manufacturing all autonomous bots. And we are currently only exporting. India is not a target audience for us currently. One more fact. We have designed an autonomous forklift, EV autonomous forklift, which goes till 32 feet, which is currently in itself a record. So here I actually want to talk about myths that surround robots. So when we go for discussions with a lot of people, they have a lot of questions about what we do and what exactly is robotics. So they have a blurred idea of what basically robotics is. They think about a humanoid robot or a 6-axis robot, and some of them even compare us to chatbots. So I'm here to tell you about what kind of robots ARAPL is into and where we are currently in development. So ARAPL, till 2021, ARAPL was mainly focused on fixed robots, which has anywhere between 2 to 7 axes. Okay, they're fixed, and their main use is is their speed, precision, as well as how they can complete a task within a controlled environment. So this is the kind of robots you will see in automotive industries. And a humanoid robot is basically a robot which has characteristics of a human, like eyes, hands, limbs, torso. A very good example of that would be If you guys would be following Tesla, they have something known as the Optimus, which I'm sure a lot of people here might have seen. So a humanoid robo will have around 26 axes, which will be in its entire body, limbs, fingers, and everything, and it is made in such a way so that it can interact with tools. But it currently in development, humanoid robots cannot match the speed of a traditional robo. A traditional robo can go up till around 20 mm per second in movement. A humanoid can't do that at the moment. Sorry. Yeah. So basically, there are some human attributes that are currently being installed within robots. So in the previous slide, I spoke about the mechanical differences between robots and humanoids. Here I'm talking about more of soft ones. Okay, so as humans use eyes, ears, the mouth or limbs from various motions, hearing, everything, a robo will be using cameras, NLP, SLM or QR. So how they use cameras is basically in a controlled environment, cameras monitor and they feed information back to a robo. And a robo will get to decide how it has to take a particular path. If there is an obstacle in the middle of a particular distance, if I suppose have to go from here till the camera, but there's this table in the middle. So the robot decides which path it has to take, depending on the information it gets from either camera or through a lidar, which is basically laser mapping. Okay? So NLP is known as natural language processors. NLP, a great example would be Siri or Siri, Alexa, OK, Google. They're basically chatbots, softbots, but you have to realize that you can speak to them. Each of you guys have your own mobile. When you were setting it up, it uniquely recognizes your voice. If I say, OK, Google, right now, your mobiles are not going off. This was something that used to happen like 7-8 years back. Right now, it has evolved to such a stage that it recognizes your voice and your commands. And it's connected to the net. In our case, when a robo is connected to an NLP, okay, so what is my use case in this? I particularly map out an entire warehouse. That a warehouse worker that is coexisting in a huge warehouse will get to know which item is particularly where. If I ask handheld device, could you guide me till the Maggie? So I would get a response as such that it would be in aisle 3, shelf 8, go till there. And it would map it out. This is it processing and getting a response back from its engine, which is the controller, which is its brain. SLM is basically a large language, LLM, large language module, which basically is it's speaking. NLP is hearing, LLM is speaking. And natural navigation or QR navigation, basically it is how these days something that's trending a lot is those autonomous cars. Autonomous cars are getting all this information through previous data, through a lot of data mining and everything. When you have to go from here till maybe, airport is a bad example, let's say fort. If you want to go from here till fort, Google Maps has already mapped out the road. We already know how much traffic there is. With cameras and natural navigation as well as a lot of sensors, a car can navigate itself these days. Basically, that's what we do with our forklifts. We map out an entire warehouse. We know where each product is. And then our robots go till that particular point as dictated by a particular order. Sorry. Yeah, so this is a learning curve basically. So humans go through a learning curve where they interact with each other through language. They know a particular syllabus of any kind of a topic. Then they choose a domain. From that domain, maybe they go into computer language. Then we give exams for it and then we get results. For robots or software bots, what do is we create a digital twin. A digital twin is basically, imagine if Boeing made 7 to 8 types of planes, but they don't want to invest in the hardware. They want to see whether the particular engines would comply. So what they do is they make kind of a simulator. So they attach the hardware to the software and they test out whatever they have to. Controller is basically what I explained in the previous slide. It's a brain. Firmware is the language inside a controller. Task teaching, if I can explain. So I would explain in more of a traditional business. Currently in robotics, what we do is, so there's something called as a pick and place robot. The task of this particular robot is pick it up, put it from point A till point B. Go back, do the same. So you teach this particular task to a robot, and then you adjust its parameters, and it keeps repeating that task. Then simulation. Simulation is basically in a particular software. If I teach this robot to go to point A to point B, but there's a particular wall in the middle. So if this task is possible or not is decided in a simulation software, and test rigs are basically controlled environments where we give them a trial, we make sure that everything that was simulated, everything that was taught is possible. So earlier you have to imagine of a robot as a human, or as a child in this particular scenario. You made your robot book smart. Now we are trying to make it street smart. So artificial intelligence is basically an intelligence quotient, and it's an adjective in a human, how you would compare it. So in our case, I'll just speak about our case. AI is a very huge topic. In our case, our AI helps our robots navigate the shortest path, manage inventories, place orders on their own. They require no human intervention for this. An adjective for learning from the peers. So we all share information, get to know a lot about different industries. A very good example would be this. All of you are here to understand about my expertise in particularly robotics. So learning from peers and machine learning have a very nice parallel. When you deploy robots throughout the country, you can put them on a kind of a server where they can communicate with each other. So if one robot learns anything on maybe, let's say, in Delhi, it can communicate within seconds to what it has learned to all the bots in Mumbai, and they can treat it as an update, they can treat it as a feature. And you would not require any manual intervention, no human intervention would be required for this. Then an adjective for data mining would be searching from the internet. Research, data mining gets a bad rep when there are certain scenarios. In our scenario, we analyze trends, inventory data. So a good example of this would be when it's early in the morning, a lot of last mile delivery apps, Swiggy, Zepto, anything that you might be using, they run out of a lot of things like milk, bread, eggs. So what these companies do is they employ softbots. They know on a particular Saturday they're going to get, if they have inventory of milk as 1,000 for that particular SKU, what they do is for Saturday they'll increase it to maybe 1,500 or 2,000. And this software learns this particular data that this is a cyclic trend. This is a cyclic trend, and in this cyclic trend, maybe rather than keeping what is the minimum quantity, let's keep more than it so that we don't run out of this particular item before it is time to be restocked. So data mining helps you learn trends of users, of end customers, and that helps in learning and predicted seasonal change, which is my next point. This is deep learning. Good example, a short example of deep learning would be seasonal trends. How we use it is basically seasonal trends. So as a warehouse, okay, you have to imagine that you have to maintain a lot of SKUs, but you don't have to maintain C-class items, which are rarely used items, throughout the year. So we know that we don't require diyas during Holi. We know that we require diyas during Diwali or lights during Diwali. So these cyclic trends send orders directly to the vendor, and those vendors prepare it and send to the warehouse without human interaction at the moment. So you don't need to maintain that inventory throughout the year and increase your cost. You maintain it only for the short duration, and a robot or an AI in this sense, or a softbot would know these trends just by implementing them for a longer period of time. Yes, this is my company's robotics journey. In 2004, we started our design export house where we were retailing parts for customers abroad. In 2008, we integrated our first robotic line. Robot was a very big myth back in 2004. Customers were not educated. We ourselves spend a lot of time trying to convince customers that give us an opportunity, we will prove you right. Okay, from then till 2024, there has been a massive change, at least in the automotive industry. In the automotive industry, you can't go these days without having robots in every shop. By shop, I will explain a bit, except the assembly shop. So basically, any automotive industry has 5 shops: engine / electronic, weld, paint, assembly, and press. So earlier, before 2004, a lot of welding was done manually, and it has a lot of harmful effects for basically the welder. It shortens the lifespan, the fumes are toxic, and the consistency, repeatability was not there. In today's day and age, when a robo came, it has changed that everything. Okay, right now, from if we talk about any car, okay, a car would be around 5 meters in length from start till end. It has tolerance of only 5 mm. Above 5 mm, it's rejected. The safety standards have increased. Okay, I'll come back. In 2013, we started our robotic car parking division. In 2015, we tried to manufacture our first mobile robot, but we failed. In 2017, we manufactured a successful mobile robot, but the price point was pretty high. It was not going to be accepted. In 2018, we got listed in the Bombay Stock Exchange SME Index. 2021, we made our first mobile robot successfully. That was like cheaper. It was way cheaper. And in 2022, we developed software boards. 2023, we developed our own simulation AI/ML softwares. 2024, we launched our product in the US. We got an order for that, got migrated to the main board, NSE and BSE. And in 2025, we are making our own digital twin. So what I'm going to point out here, from 2004 till 2021, we were only focused on fixed robots, okay? And from 2021 till date, we are focusing on mobile robots because the trend in the industry is changing. This is our vision, solution for autonomous interconnected logistics, which is SAIL. What I want to explain here is our product cycle for anything would be that it is made inside factories, it's sent to a port, then from a port it goes to the warehouse, and from the warehouse it goes to last mile and it is delivered to the customer. All of these have a possibility of going completely autonomous, and we are currently working on these products. This is actually the market size that ARAPL is targeting. Warehouse automation throughout the world for AI bots, forklifts and such is around 300 billion. Robotic welding globally would be around a $12 billion industry. Smart parking would be around a $34 billion industry. And ARAPL is targeting, ARAPL is competing in this industry for a total of 350 billion. Okay. And yeah, this is our go-to-market strategy basically. So we started selling software and hardware back in 2021. We customized the softwares to address the pain points of our customers, and we even gave them a model because see, it's a capex heavy product. So we gave them a choice to pay as they use to reduce their capex. So we've already identified 5 channel partners across US. We have partnered for sales and service with Toyota, Lyft, Northwest, and our phase 2 would be that we are going to launch operations in Europe and Middle East. So with that, I would like to thank you. Thanks a lot for this opportunity to speak.
Thank you, Rahul, for this presentation. I'm one of the lucky guys to visit the Affordable Robotics facility in Pune. But that apart, one of the questions that I was getting is about scalability and cost. As you were mentioning that, the cost economies has fallen over the period since you have started developing. For mobile robots, how do you really look at cost getting more effective? And, the entire value chain, how is it more affordable, especially in the US markets or any warehousing logistics provider, even in India?
So, a couple of things about this. For fixed robots, I will start with just the fixed robots. The fixed robots cost is constantly reducing. If you were looking at 2004, the same product would have cost today around 17 lakhs, which will cost you around 7 lakhs today. Okay? There's a lot of competition and reduction of monopoly. The price is already decreased. When it comes to mobile robots, see, I do see cost reducing, but the cost reducing will be around 8 to 9 years. And till then, I don't think India is the correct audience for it, because manual labor is still very cheap. Because current warehouses, like city warehouses, would have 5,000-6,000 people, and that would be still cheaper to them than getting a robot. They are currently focused more on growth and less on reducing costs.